A copper cube of mass 200 grams slide down on a rough inclined plane of inclination 37 degrees Celsius at a constant speed. Assume that any loss in mechanical energy goes into the copper block as thermal energy. Find the increasing temperature of the block as it slides down through 60 centimeter. Specific heat of copper is given. Alright. Now let us say this is my inclined plane at which a block slides. The angle of inclination is 37 degree and blocks comes down. Alright. Now again this question is simply energy conservation. Initially it is having a kinetic energy and a potential energy. Let's say this is my height h. So initially it is having some potential energy. Alright, it slides down to 60 centimeter down. So clearly that kinetic energy is same, that is it is having some initial kinetic energy. Alright, let it be initial, and also that is equals to the final kinetic energy, because it is not stopping. The kinetic energy is the same, but what is changing is the potential energy. It is having some potential energy and final potential energy is less because it is sliding down. So the change in potential energy will be equal to mgh, and mass is given as 200 grams or 0.2 kg into 9.8 into h. Now clearly sine 37 is h by 0.6, so h can be written as 0.6 sine of 37. So this is my change in potential energy, and by energy conservation the change in potential energy is equals to change in thermal energy, and the thermal energy is given by mc delta T. So I do have a mass as the same, that is 0.2. Specific heat of copper is 4200, and delta T I think it is 420. Alright, so into delta T. So delta T from it comes out to be 0.2 into 9.8 into 0.6 sine of 37 divided by 0.2 into 420. So delta T comes out to be 0.0086 degrees Celsius. That is my answer.